Good morning, everyone. My name is Suraj Sir, and today I'm going to talk about the topic TCP/IP model, which is also known as Transmission Control Protocol or the Internet Protocol model. The OSI model is just a reference or logical model. It was designed to describe the functions of the communication system by dividing the communication procedure into smaller and simpler components. But when we talk about the TCP/IP model, it was designed and developed by the Department of Defense in the 1960s in the USA and is based on standard protocols. It stands for Transmission Control Protocol or the Internet Protocol. The TCP/IP model is a concise version of the OSI model. It contains 4 layers, unlike 7 layers in the OSI model. The layers are application layer, transport layer, internet layer, and network access layer. Now, if you see the diagrammatic representation of both the layers, that is OSI model and the TCP/IP model, it looks like this. Here we had the OSI model, which had 7 components under it. Number 1 was application layer. Number 2 was presentation layer. Number 3 was session layer. And then we had transport layer. After that we had network layer. Just a second, network layer. Then data link layer. And in the very end, at the bottom, was the physical layer. This was the OSI model, which composed of 7 layers. And now when we talk about the TCP/IP model, it has only 4 layers. TCP/IP model. Number 1 is the application layer. Then we have the transport layer. And then the internet layer. And then a final layer is network access layer. So this is the model of the TCP/IP. Now let us talk about some of the differences between the OSI model and the TCP/IP model. Now the TCP refers to Transmission Control Protocol, whereas OSI refers to Open Systems Interconnection. TCP/IP has 4 layers, whereas the OSI model has 7 layers. TCP/IP is more reliable, whereas the OSI is not. TCP/IP does not have very strict boundaries, whereas OSI model does have very strict boundaries. TCP/IP follows a horizontal approach, whereas the OSI model follows a vertical approach. TCP/IP uses both session and presentation layer in the application layer itself. OSI uses different session and presentation layers. Now these are some of the differences which we talk about between OSI model and the TCP/IP model. Now let us talk about each and every layer. Let us talk about each and every layer in the TCP/IP model. At first we have the network layer, network access layer. This layer corresponds to the combination of data link layer and physical layer of the OSI model. It looks out of hardware addressing, and the protocols present in this layer allows for physical transmission of data. We just talked about ARP being a protocol of internet layer, but there is a conflict between declaring it as a protocol of the internet layer or network access layer. It is described as residing in layer 3, being encapsulated by layer 2 protocols. The next layer we have in the TCP/IP model is the internet layer. This layer parallels the functions of OSI's network layer. It defines the protocols which are responsible for logical transmission of data over the entire network. The main protocols residing in this layer are: number 1, the IP or the Internet Protocol, and it is responsible for delivering packets from the host source to the destination host by looking at the IP addresses in the packet headers. IP has two versions, IPv4 and IPv6. IPv4 is the one that most of the websites are using currently, but IPv6 is slowly growing as the number of IPv4 addresses are limited in number when compared to the number of users. At number 2 we have ICMP, which stands for Internet Control Message Protocol. It is encapsulated within IP datagrams and is responsible for providing hosts with information about network problems. At number 3 we have ARP, which stands for Address Resolution Protocol. Its job is to find the hardware address of a host from a known IP address. ARP has several types: reverse ARP, proxy ARP, gratuitous ARP, and inverse ARP. The next layer in the TCP/IP model is the host-to-host layer, also known as the internet layer. This layer is analogous to the transport layer of the OSI model. It is responsible for end-to-end communication and error-free delivery of data. It shields the upper layer applications from the complexities of data. The two main protocols present in this layer are: number 1, Transmission Control Protocol, which is the TCP. It is known to provide reliable and error-free communication between the systems. It performs sequencing and segmentation of data. It also has acknowledgement feature and controls the flow of the data through flow control mechanism. It is a very effective protocol but has a lot of overhead due to such features. Increased overhead leads to increased costs. Then we have at number 2 we have User Datagram Protocol, the UDP. On the other hand, does not provide any such features. It is the go-to protocol if your application does not require reliable transport, as it is very cost effective. Unlike TCP, which is connection oriented protocol, UDP is connectionless. The variant layer of the TCP/IP model is the application layer, which is sitting at the top, which is also the topmost layer. This layer performs the functions of top 3 layers of the OSI model: application presentation, and session layer. It is responsible for node-to-node communication and controls user interface specifications. Some of the protocols present in this layer are HTTP, HTTPS, FTP, TFTP, Telnet, SSH, SMTP, and many more. Now let us talk about some of the important protocols in this layer. Number 1 is the HTTP and HTTPS. You must have always read on, I'm sorry about that noise. Okay, you must have always read on any website, on any link, there's the first 4 or 5 letters are either the HTTP or HTTPS. Now let us talk about what they are. HTTP stands for Hypertext Transfer Protocol. It is used by the World Wide Web to manage communications between web browsers and servers. HTTPS stands for HTTP Secure. It is a combination of HTTP with SSL, which is Secure Socket Locket layer, and it is efficient in cases where the browser needs to fill out forms, sign in, authenticate, and carry out bank transactions. Always remember, if you are making any online transaction or you're filling out an important form online, always look for HTTPS linked websites. Alright, the second protocol in this layer is the SSH. SSH stands for Secure Shell. It is a terminal emulation software similar to that of Telnet. The reason SSH is more preferred is because of its ability to maintain the encrypted connection. It sets up a secure session over a TCP/IP connection. The number 3 protocol is NTP. NTP stands for Network Time Protocol. It is used to synchronize the clocks on our computer to one standard time source. It is very useful in situations like bank transactions. Now assume the following situation without the presence of NTP. That would be very hostile. Suppose you transaction where your computer reads the time at 2:30 p.m. while the server records it at 2:28 p.m. The server can crash very badly if it's out of sync. So these were the four basic layers, the four main layers in the TCP/IP model we just talked about. Thank you very much for paying your attention and have a good day. Bye.